So in this section, we will study about addition and subtraction of vectors. So suppose if we want to add two vectors, let us say this is one vector, this is a fourth vector, this is, let us say, 3 Newton, and we want to add another force which is, let us say, 4 Newtons. So will this be equal to 7 Newtons? The obvious answer is no. Why? Because we cannot add vectors as scalars. To add two vectors, we need to consider their directions along with their magnitude. So vectors cannot be added by scalar algebra. To add or subtract vectors, we need to have vector algebra. There are two laws which can be used to perform addition of vectors. So two laws, in which first law is triangle law of vector addition, triangle law, and the second law will be parallelogram law. So first let us discuss triangle law of vector addition. In triangle law of vector addition, if we take two vectors, let us say this vector be vector A and this vector be vector B. If we want to add these two vectors A and B, we have already seen that vectors can be shifted parallelly in the space. So we need to arrange these two vectors one after another in such a way that A vector is the first vector and the tail of B vector will touches the head of A vector. So this is vector A and this is vector B. Then the resultant of these two vectors will be given by third side of the triangle. Let us say this vector be R. This equals to vector A plus vector B. So this is the way we can add two vectors by triangle law of vector addition. We can also do it if we take first vector as B. So if we take first vector as B and then second vector as A. So this is first vector B and this is second vector A. And if we want to add these two vectors B and A, we will get this vector. So this is the vector R and this is equals to vector A plus vector B. Now we can clearly see that in both the cases the resultant is same. It is just parallelly shifted. Now from here we can state the triangle law of vector addition as, so when two vectors A and B are represented by two sides of a triangle taken in order, then the resultant is given by third side taken in reverse order. So if we wanted to add two vectors A and B, we need to represent it by two sides of a triangle. So this is, let us say, one side A and this be the another side B. And we have taken these two sides in one order. Then their resultant R is given by the third side taken in reverse order. So this is R is equals to vector A plus vector B. So this is the triangle law of vector addition. Now based on this triangle law of vector addition, we can solve some geometrical problem. Now in these examples, we need to determine vector A plus vector B by using triangle law of vector addition. So we can rearrange this vector A and B in the first case as, so this is vector A and this is vector B, as we can parallelly shift vectors into the space. So this we can write as vector A and this we can write as vector B. Now the vector C or the resultant of this vector is given by this vector. So this is vector R, which is equals to A plus B. Now in the second case, we can rearrange these two vectors as, this is, let us say, the first vector A, and we can parallelly shift this vector at this position. So if we shift this vector at this position, this will become vector B. Now the resultant will be this vector. So this is vector R. Now in the third case, we can write, let us say this is vector A and this is vector B. So this is vector A and this is vector B, and the resultant will be, so in all these three cases we have taken vector A and B in one order and the resultant is taken in reverse order. Here A and B is taken in anti-clockwise and the resultant is in clockwise. Similarly here A and B are taken in anti-clockwise and the resultant is in clockwise. Similarly, in last case we can take, this is vector A and this is vector B. So this is vector A and this is vector B. So here we have taken A and B in clockwise. Now the resultant will be this vector. So here resultant is taken in anti-clockwise. So this R. So these are the resultant of vector A and B in all these four cases. Now let us try to understand subtraction of vectors. Now there are two ways in which we can determine subtraction of vectors. So let us first discuss method 1. First method. Now in this method, if we want to add two vectors, let us say if this is vector A and this is vector B, the resultant vector will be C. So if this vector is A, this vector is B, and the resultant vector is C. So here we can write vector A plus vector B is equal to vector C. Now if we rearrange this equation, we can also write vector C minus of vector A is equal to vector C. Now what is vector C? This was vector C. What is vector A? This is vector A. So if we subtract A vector from C vector, we will get B vector. What does it mean? It means if we subtract these two vectors, suppose if this vector is P and this vector is Q, and if we subtract Q from P, we will get this vector. Let us say this vector be R. So R is equals to vector P minus of vector Q. So in this way we can calculate subtraction of vectors. So how to subtract two vectors? We need to make first vector from which we need to subtract another vector. So we can join these two vectors from tail to tail. And if we want to subtract vector Q from vector P, the resultant of subtraction will be the another side of triangle joining both of their head, and we have P minus Q is equal to R, and the head of R is towards the first vector, that is head of R is towards the P vector. So this is resultant vector R, which is equals to vector P minus of vector Q. Now let us try to solve some problems based on subtraction of vectors. So in all these problems, we need to find out vector A minus of vector B. So we already know that we can parallelly shift two vectors. So in the first case, this is, let us say this is vector A, and we can shift vector B over here. So this is vector A and this is vector B. Now we have to join these two vectors from tail to tail. Now the resultant of A minus B will be the third side joining their head, in which A minus B, if we are writing A minus B is equals to R, so the head of R should be towards A. So head of R should be towards A. So this is A and the head of R should be towards A. Now in the second case, suppose if this is vector A and we have to shift this vector B, and this is vector B. So this is vector A and this is vector B. So the resultant of these two vectors will be the third side, and the resultant and the head of R is towards A. So this is R, where R is equals to A minus of B. Now similar in the third case, if we have two vectors, let us say this vector be A and this vector be B. If this vector is A and this vector is B, the resultant will be in this direction. This vector be R, which is equals to A minus of B. Similarly, in the last case, fourth case, we have to join two vectors from tail to tail. So this is vector A, and if we join the vector B from tail of A, this vector will be B. So this is vector A and this vector will be vector B, and we need to find out vector A minus B. So this vector will be the line joining two heads of two vectors. So this vector will be vector A minus B, and this R is equal to vector A minus of vector B. This method is little bit tricky, but practicing this method will give you more benefit. Now let us try to see the second method. So this is method 2. Now here, if we want to subtract two vectors, let us say if we want to subtract vector B from vector A, and we need to determine vector A minus vector B. We have already defined negative of a vector, so this equation or this operation can be written as vector A plus of minus of vector B. So in this method, we are not subtracting any vectors, we are actually adding two vectors. One vector is A and another vector is negative of vector B. We have already defined the negative of any vector. So in this case, we are adding two vectors, not actually subtracting two vectors. So what we are doing here, we are adding vector A and minus of vector B. So if we want to subtract, let us say if this is vector A and we want to subtract another vector B. This is, let us say this vector be B. Now we can rearrange these two vectors as, so this vector is A and this vector is B. This vector is A and this vector is B. And we have already seen that a negative of a vector has same magnitude but opposite direction. So minus of B will be in this direction. This is minus B vector. Now what we need to do, we need to shift this minus B vector at this position. So let us say this be the second vector, that is minus of B, and we need to find out vector A plus minus of vector B. This will be equal to this vector. So this vector will be, we can say that it is equals to vector A plus minus of vector B. So we are using, so here we are using technique of addition to determine subtraction of vectors. Now let us try to take a very simple example, and we will try to solve this example by both the methods. So in this example, a car is moving towards north with some speed, let us say V, and then it takes a sharp right turn towards east. Then it takes a sharp right turn towards east with the same speed. We need to find out the direction of change in velocity. So here we need to find out the direction of change in velocity. So let us try to solve it by method 1. Method 1. Now what is the meaning of change in velocity? So the change in velocity, as we already know that velocity is a vector quantity, so change in velocity is the final velocity vector minus of initial velocity vector. Now we can represent final velocity and initial velocity by two vectors, and we need to determine the subtraction of these two vectors. So here, this is the final velocity, which has the same magnitude, this is equals to v, and this was initial velocity. We need to join these two vectors from tail to tail. So this was the initial velocity and this was the final velocity. This is final and this was initial. Now we need to find out the direction of change in velocity. So change in velocity will be final velocity vector minus of initial velocity vector. This will be equals to this vector, and its head is towards the first vector. This is final velocity. So this head will be in this direction. So here the direction of change in velocity, we can say that it is southeast. Now try to solve the same problem by second method. Now in this method we can write change in velocity or delta v vector can be written as final velocity vector plus of negative of initial velocity vector. So final velocity vector was this and initial velocity vector was this, and negative of initial velocity vector will be this. So this is v and this is minus of v. So this is initial velocity vector. Now we need to add these two vectors. So if we add minus of v with final velocity, we will have this. This is final velocity and this is minus of v. This is the direction of minus of v. So addition of these two vectors will be in this direction. As we can clearly see that this direction is also southeast as we have obtained in the first method. So this is the way we can perform subtraction of vectors.